Okay, good morning. Welcome to
FamilyMath1171.
FamilyMath1171. So we're continuing the project we did yesterday. In fact, the writing's still on our board. Where's that sheet of paper that explained what the problem was? Okay. So we're talking about something called the paradox of the second ace. And so it says if you're playing bridge, and so in bridge you're going to get 13, be dealt 13 cards. If you ask the question, do you have at least one ace? And you answer yes. The chance of having a second ace is about 37%. But surprisingly, or somewhat surprisingly, if you say, do you have the ace of spades? And you say yes, the chance of having a second ace is about 56%.
Yeah.
So yesterday we were able to replicate the calculation and get the 37%.
Yes, we did.
And so today we're going to try to do the second one. If you have the ace of spades, what is the chance that you will have more than one ace? So how are we going to do that calculation?
Okay, so I think we have the probability of having more than one ace already written out from last time. And so we just need to find the probability that you get the ace of spades.
Well, yeah, we're doing actually kind of the opposite of that. We're doing if you have the ace of spades, what's the probability that you have more than one ace? So not the probability. Oh, maybe it's the same. But you were saying here's the probability of more than one ace. What's the probability that you have the ace of spades in this situation? But let's do it the way the problem is. So if you have the ace of spades, what's the probability that you have more than one ace?
Okay, so let's see, having the ace of spades. Well, basically...
I guess I can erase all of this except for the total number of hands, right?
Yeah.
Okay. So
let's see.
How many hands have the ace of spades?
So looking at the ace of spades, it's just one specific card. So that's fixed. So say if we have it in the first card position, it would be 1 times, and then the rest of the cards you choose randomly. So 51 choose 12.
Okay, good.
And that's having the ace of spades.
Alright, so there's 51 choose 12 hands that have the ace of spades. Because, you pick the ace of spades and then you just pick 12 cards from the remaining 51.
Yes.
Now, how many of these have more than one ace?
Okay. So, let's see. I guess we can do, looking at the 51 choose 12 cards, we're just looking for the ones that have at least one ace out of those. So I think we can do a similar complementary counting technique and look at the ones that have no aces.
Okay.
So, let's see. The ones that have no aces are, out of the 51 choose 12, you're getting rid of 3 cards to choose from. So you have now 48 choose 12.
Okay, yeah.
And these have no aces and 12 cards.
Alright.
And then I guess we just subtract that away from the 51 choose 12.
Okay. So the number that have at least one ace, at least 2 aces, is 51 choose 12 minus 48 choose 12, because 48 choose 12 is the ones that had no extra aces. Okay, great.
At least one ace plus the ace of spades.
Yep.
Okay, so then we've got our 2 probabilities, and now We just need to do this probability.
Well, that's not a probability. That's a count
Just
of
the amount.
Yeah.
To find the probability that we want, we do this divided by this.
Yep. And I have the exact number written down on a piece of paper.
Right.
We're hoping this is going to be 11,686 out of 2825, and which is about 56%.
All right. Cool.
Okay, so why don't we check that on the computer, and then we have a little simulation that we wrote.
Okay.